All right, so we've got a related rate problem here. It says water is leaking out of an inverted conical tank at a rate of 10,000 cubic centimeters per minute. At the same time, water is being pumped into the tank at a constant rate. The tank has height 6 meters, and the diameter at the top is 4 meters. If the water level is rising at a rate of 20 centimeters per minute, when the height of the water is 2 meters, find the rate at which the water is being pumped into the tank. All right, so let's take a look at this. Let's draw a picture. So I've got a inverted conical tank. All right, and it tells me the diameter is 4 meters. So that actually gives me, I can say the radius is 2 meters. And the height they give me is 6 meters. All right, now what they're looking for is find the rate at which the water is being pumped into the tank. Well, let's see what else it gives us. The tank, let's see, if the water level is rising, so it tells us about the water level. So let's sketch that in. So here's the water level. That distance is R. And the height of the water is H. Okay. All right, so let's look and see what all we need to do. All right, so this has to do with volume. Okay. Well, what's the volume? What's the volume of the cone? Well, the volume is equal to 1/3 pi r squared times h. That's the volume. Well, let's see what all we have. It says water is leaking out at 10,000 cubic centimeters per minute, and at the same time, water is being pumped into the tank at a constant rate. All right, and in the end, they want to know the rate that the water is being pumped in. They want to know this rate right here. So let's do this. We're going to let C equal the rate that the water is being pumped into the tank. All right. So look at this. We got to write down all the information that they give us. Let's write down what they're wanting us to find also. All right. Well, we know what they want us to find. That's C. All right. So on this V here, well, if you notice, they give us the change in volume, dV dt. That's just what? C minus 10,000. The rate in minus the rate out. Okay, that's going to be the change in volume. And then they tell us the water level is rising at 20 centimeters per minute. So that's telling us dH dt. So dH dt is equal to 20 centimeters per minute. And then they want to know, let's see, it's when the height is 2 meters. Okay, so let's look at this. They're giving us dH dt. They're not giving us anything about the change in the radius or anything. So it looks like since we got dH dt, and they're also telling us when the height of the water is 2, we're going to have to get this all in terms of h. So we're going to have to get R in terms of H. Well, let's come over here and do that. So I've got, let's see, this radius over this radius is equal to this height over this height, a proportion, right? So I've got R over 2 is equal to H over 6, which that tells me R is equal to 1/3 H, right? So now let's plug this into here for R. So I get V is equal to 1/3 pi times 1/3 H squared times H. So V is, well, this term here is what? That's 1/9 H squared. So if I multiply it, that's going to give me 1 over 27 pi, and then H squared times H is H cubed. All right, so there's that. So there's my function. So now let's go ahead and take the derivative with respect to t. So I get dv dt is equal to 1/9 pi H squared, the 3 comes down, subtract 1, dH dt. Okay. All right. So remember what we're looking for. We're looking for C. Well, I can replace dV dt with C minus 10,000. So that's going to be C minus 10,000 is equal to 1/9 pi. Now let's plug in our value for H. Well, they tell us that H is equal to 2 meters. Okay. But notice that the dH dt is in centimeters per minute. So we need to convert this to centimeters. So 2 meters is equal to 200 centimeters. So that's going to be 200 squared times dH dt, which is 20. All right. So solving this, I'm going to get C is equal to, now let's see, when I multiply this well, let's just do this. Let's write this as 200 squared times 20 pi over 9 plus 10,000. Move the 10,000 over here. All right. And so when you punch that into your calculator, you get 289,253, and then that is going to be cubic centimeters per minute. And so that would be our answer. So this one was, there's a little bit to this one, but it wasn't bad. So check out my other videos. Hope this helped. Give me a like, share, and subscribe, and thanks for watching.